Hello everyone, welcome to my channel Digital Dynasty, which promises to help you learn tech at speed and scale. This is my very first video for this channel, and I love to inaugurate this by launching a C programming language tutorial. So let's get started. So before we dive deeper into C programming language, I would like to set some context in terms of what is to be expected as part of this short tutorial. So here I'm planning to address the no voice or people who are absolutely new to programming and would like to introduce the theoretical concepts of C programming language before diving deeper into the actual implementation. So here we are just going to learn about the theory first, and there will be a separate tutorial video to have an hands-on practice. Thank you. Let's begin with the introduction of C programming language. As most of you must be aware, it was invented or developed by Dennis Ritchie at Bell Labs earlier in 1917s, and the compiler was launched around 72. There were multiple versions and revisions to the C language, and the latest one, which is available in the market or the preview release, is for C23, but it is yet to be launched. And this, the most stable version, which has been used in the industry, is C17, but there is also release of C18, with bug fixes and clarifications in 2023, though it was initially released on 2018. So that's about introduction. Before when we learn any programming language, it is important to understand why should I learn that language and how what value really does it add to me as a programmer or as a developer or as a generic engineer. What sense does it make sense to me to learn C programming language? Well, definitely yes, because most of the programming languages that you'll come across throughout your career, either it be Java, it could be any damn, it could be Golang, it could be Python, whatever language that you choose. The foundation of all these languages, the data structure concepts of all these languages will be clarified for you, and it would be cakewalk for you to learn any damn language on the surface of the earth if you know the fundamentals of C very, very well. So it's a foundational language, and I would encourage each and every one of you at the beginning of your career to definitely learn this language and to learn and to, I would rather say, you should kind of achieve mastery in this language, which will set a path for you, and rest of the languages will be kind of cakewalk for you to learn. So so this is a foundational language and you should definitely learn it. As far as the applications of this language are concerned, some of you may be interested into, getting into systems programming or embedded programming. So this language is extensively used to at system levels as well as for embedded programming. It is used even at microcontrollers, at microprocessor levels to, make the data structures work. Also, it's important to note that the most of the legacy systems that the banking domain has are, or trade finance systems are developed in C and C++, and it becomes easier to update and maintain those existing code bases, though they may not be entirely on the latest and greatest technology. So knowing this helps you work with it, kind of opens opportunities for you to work in different domains, specifically banking. Next important uh, uh, point here is, it is, like I said, it's a fundamental language, and most of the new programming languages, be it Golang, if you see, is an advanced version of C, wherein some features of C have been defined and fixed. So it's crucial from, education perspective. Also, it's a low level control. It's a language which allows you to have low level control over a lot of system resources. So in a gist, it is important to have, one foundational language. It is important for you to learn if you have interest in going into embedded or systems programming, even if it will help you, set your base initially in any of the domains, business domains, or any of the banking systems that you end up having your job with. And overall, I would say it's a win-win for everyone to have language of this, have knowledge of this language, as well as have hands-on programming skills for C. That's about it. So, as any language, when we learn any language, there are two aspects to it. First is the syntax, and then it's the semantics. So, syntax covers how we talk in that language, how we make the compiler understand the programming language, and the semantics is your logical structure of the program or the algorithm. So, these are the basic, syntax of C, which is standard across most of the programming languages. This is how we define a semicolon. This is how we define the braces. Variables are used to declare different data types. Functions are used. Functions typically have a return type, and you need to pass the parameters and they will return some value, and they definitely have a name define themselves to the compiler. Control flow statements, there are multiple control statements called if, else, switch, for, while, and do while, which we will see in detail in the subsequent sections. As far as ordered collections or collections of similar items or items of same kind, such as integers, floats, doubles, longs, etc., are stored into a data structure called as array, with the type and the size defined at its definition. Pointers are used to hold the memory addresses, and they are actually a very powerful manipulation tool to manipulate the content at the specific memory address. You'll also see different user-defined data types such as structures and unions as we dive deeper into this course. As far as memory management in C is concerned, there are different functions such as malloc, alloc, dealloc, or deallocation functions or free functions to allocate and deallocate memory spaces. Like I said, these are kind of examples of how to define different types or different kinds of data types in C, variables and constants. So typically, you'll have around six to seven data types. You have integers, you have float, you have characters, you have double, short, long, etc. So this is this classic definition of how a variable is to be defined to a compiler: a floating variable, a character variable. Similarly, variables at the declaration, if you do not assign any value to the variables, then they are assigned some garbage value. Unless you're explicitly defining any variable, assigning a variable any value, a garbage value gets assigned by the compiler, by the memory management system. So count of 10 assigns the value of 10 to the of variable count of type integer. Similarly, same thing applies for float. Constants are nothing but the variables which will not change their value. So you need to assign a definite value by using the keyword const. Let's look at the take a look at C control flow statements. So like I said earlier, there are couple of or I would say multiple control flow statements in C. First one is if else and switch statement. So this is an example of how you could typically code for an if else kind of a statement and a switch statement, which may sound like an if else, but the applications or the conditions in which we use if else and switch statements are different. So consider a scenario wherein you just have a few set of conditions and simple logic is to be written. Then you would typically go for an if else. But if you have multiple conditions or multiple scenarios and you want to have better improved, readability and maintainability of your code, then it makes more sense to have a switch statement which will execute. In a switch statement, you're required to pass a parameter which is nothing but a case value, and based on the value that you pass, respective case code would get executed. If the parameter doesn't match to any of the cases, then the default case gets executed. These are some other examples of additional control flow statements in C. So we have a standard for loop which will repeat itself as long as the condition of I less than 5 is met. Similarly, we have a while loop which executes the block of code while the condition is true, and a do while loop wherein the code will be executed once because the while condition is checked towards the end. So this is a typical example which we will cover in the next tutorial. This is just an example of how you can write a for loop, a while loop, and a do while loop in C programming language. Functions. So I would just like to talk a little bit about functions here. So functions are nothing but if we put, they are just pseudocodes, but we want to have a value to that pseudocode, and we would definitely want to have some inputs and outputs. So there are two aspects to a function in C. First is declaration. Declaration is done to inform the compiler that this is my function and this is the signature of the function. When I say signature of the function, it is nothing but the type of the value that the function would return, and the name of the function, and the parameters of the functions defined within the parenthesis and ended by a semicolon. So declaration is what you tell is nothing but the signature of the function to help compiler understand what it has to process. And implementation or definition of the function is nothing but an actual logic that gets written within the two braces of the function. So for example, here written a plus b is going to return addition of a plus b. Parameters and return value. So like I said, function signature has the return type, the function name, int a and int b are the parameters, and return value is nothing but the logic that gets computed, and whatever is the result gets returned to the corresponding uh, variable which is going to collect the value from that function. Hope this clarifies. So similar to, in order to process same set of data, we have concepts of C collections. C collections are nothing but arrays which will store similar data type in contiguous memory locations. So how do we typically declare an array in C? So when we declare or define an array in C, we are supposed to specify the kind of variables, it's kind of data it's going to hold, and the number of contiguous memory blocks that you want to be blocked. Because in C, you need to specify this so that the continuous memory allocation happens inside the memory. So this is the standard declaration of arrays in C. Assigning array values to the array elements. You could also declare it like this so that respective values get assigned to the memory locations assigned in the array. Accessing the elements. When you have to access the elements, you typically indexing starts at 0. So say for instance, if I want to access 1, I would say number of 0. For 2, number of 1. So this is a very crucial point that you need to understand, that indexing for arrays always starts with 0, and you need to iterate from 0 to 4 to access all 5 elements of an array in the C programming language. Memory management. This is very interesting. So memory management is done through pointers. Okay. So pointers is nothing but the address of a specific memory location. How do we declare a pointer in C? So typically any kind of pointer holding that specific data type is defined using the type of the data and using a star symbol with the variable name, which is nothing but the pointer variable. This is how we declare a pointer. How do we initialize a pointer? Let's say we have a pointer PTR and we have a number 42 and I want pointer to point at the memory location or address of number. So we say int pointer is equal to and of number. When we say ampersand, what the compiler understands here is that I have to point, PTR needs to point to the hexadecimal address of number and not the value of the number, and not at and PTR will hold the hexadecimal address of the memory location where value 42 gets stored. How do we accessing dereferencing the number? So when it comes to dereferencing is you could assign int and ask it to hold the address of the pointer. So you can also keep on passing on the address by using accessing the value at the memory address is nothing but, so if I unless I do a star here, it would not point to the address. Here int is an integer, it is not a pointer. So here star of pointer is nothing but the value of 42 would get assigned to the variable value. Memory management. So there are various techniques, which C programming uses for managing the memory. So typically it is managed via stack and heap. So there are fundamental differences in which the memory allocation happens in a stack and a heap. So stack is the memory is allocated for function calls and local variables. This is stack is, like I said, we use C for managing the programs at system level. So this gets the management of the stack happens automatically by the compiler, and it is faster access, but there is limitation in terms of the size. Vis-a-vis, if we talk about heap, heap is nothing but a dynamic memory allocation for all the data structures. So this requires a small memory management and memory fragment to manage, and this this does have a slower access compared to stack, but it is kind of dynamic. It is not static like a stack. So we did talk about functions. So all the functions in C are managed to stack data structure. We will talk about stacks, queues, etc. in the advanced C programming tutorial. But for the time being, in order to keep it very light, we just focus on stack as nothing but an inverted queue. All right, wherein in a queue, typically a person who enters first in the queue is expected to enter first out of the queue. But in case of a stack, the person who enters first in the queue will be the one who comes last out of the queue. So that stack is nothing but a vertical queue. It's an inverted queue. So in C, stack is used for function calls and local variables are managed automatically and is faster but limited. And heap is nothing but, like I said, it's a dynamic memory allocation. It is manually managed and it is typically slower because it is manually managed. When it comes to heap, we spoke about dynamic memory allocation. So there are certain functions which are used, which C provides for dynamic memory allocation, which is nothing but malloc. So when I want to allocate a memory of for an integer variable, then I need to say malloc and size of int as the so that it will block 2 blocks inside the memory. And free is nothing but dynamically releases the memory which to which pointer is pointing. In C, memory allocation happens through malloc on heap, and free releases the memory, or as in deallocates the memory so it can be reused. And this is extremely important, because unless you free the memory, there would be a lot of memory leaks. As in, say for instance, you use the pointer which was pointing to an integer variable, and you no longer need a pointer, so there are a lot of dangling pointers sitting inside the memory which are kind of wasting the memory and reducing the processing efficiency of your program. So this is very important point to remember, that you always need to free the memory or the pointers which are dangling inside the memory space or which you no longer need. Like I said earlier, C also has user-defined data types. So there are two types of user-defined data types in C, which are nothing but structures and unions. They're fundamentally, uh, brought into picture so that they can hold kind of different data type information. So structures, if we see, is a composite data type that groups variables of different types under one name. Say for instance, person. So person has different characteristics attached to him or her. Is the name of the person, the age, the height, the qualifications, etc. Though the categories of this, the nature of the data is different, but it is attached to a single entity. So it is used to group variables of different data types that are attached to a single entity. Vis-a-vis unions, these are special data types that allow storing different data types in the same memory location. So let's kind of break this down a little bit further, and let's get into how we typically define a structure and how we typically define a union, and how are the members accessed inside these user defined data structures. So here, if we take a look, structures are declared and initialized and accessed using a dot operator to manipulate the related data as a single entity. All right. So this is how typically a structure is defined. The keyword is struct point integer x integer y. How do I initialize the structure variable is nothing but by defining a variable of type structure point. So p1 is my variable, is a structure variable to which I'm assigning values 3 and 5. These are nothing but placeholders for x and y. And how do I typically access the members? Say for instance, I want to assign 3 to some other variable, then I need to define the variable and I need to say p1 dot x. So this is how we typically define, assign and access variables of a structure data type. Unions. Now, what is different about unions? So unions are allowed to share memory for different data types, saving for efficient space management when only one type is used at a time. Now, let's take a look at the uh, union data type. So let's understand the definition here first. A special data type that allows storing different data types in the same memory location. This is the takeaway, same memory location. So what do we mean by that? Let's take a look at the example. So define a union. So if you see, the definition is almost similar to that of a structure, but the memory management is different in structure and a union. How do I create a union variable? Create a union variable is union variant data. So this is the union keyword. The name of the union is variant, and this is my variable. How do I share memory for different data types? So here int value, I am assigning a value of uh, uh, int value is my integer data type inside a union, and I'm assigning a value of 42 to it. But union allows storing different data types in the same memory space, enabling efficient use of memory for various purposes. So I can also assign a float here. So let's say float value and also assign a float here. So memory management is hidden, but you need to understand what makes sense for you from the application's perspective as to what kind of data you want to use. Either a structure or a union is the user's choice. Next important is file handling in C. So we'll take a look at how file management is done in the C at a very high level. So standard functions for managing the file are: we have to open the file, we have to create the stream, we have to read the file, we have to print the file, we have to close the file. Okay, so the standard functions which we use in C are fopen, fread from the file, fwrite from the file, fscanf are used to read the data in a specific format, and fprintf is used to print the data in specific format. And fclose is a function which is used to close the file pointer or close the connection to the file when the when a job of reading or writing is done, or streaming from the file is done. So let's take a look at the example of how do we open a file. So we need to define a file pointer. Fopen function give the name of the file and the mode in which we want to read the file. So here the mode defined is read. So reading from a file, read data from a file. So example is fscanf. I could just say a scanf here and not give the percentage D here if I just want to read the number and not have a proper formatting. So fscanf, this is the file pointer and I want to read this, and this is my data type. So from this particular address, the value would be copied to percentage D and we will be printing it. So percentage, the number is percentage D of number. We'll take a look at these as to how we print in a later section. So closing a file is fclose file pointer. Let's take a look at the example of how the typical, we'll take an example of writing the same code in the flow. So close the file, close, read and write is, we could also do a buffer read when you want to read a character by character, and print character by character, or print a buffer. So it's up to you how you want the buffers, how you want to read and print the file. So there are functions available even for buffering. There are functions available for systematic reading as well. So you can explore this more when you start reading and writing your own files. So there are a lot of functions that the C standard library helps us to, write different kinds of code and the manner in which you want to handle the files. The standard files that we definitely need to incorporate at the beginning of your C program is STU. This is used for standard input out Studio H. We used to call it Studio H, STDIOH. Memory allocation is standard library.h. Memory allocation and conversion functions. String manipulations, you need to incorporate string.h. For mathematical functions, math.h. Time and date functions, time.h. Examples are, examples in which, or the functions which are defined in stdioh are printf, scanf, malloc and alloc from free standard library for memory management, string functions, copy, length, etc., syncos from math, time, ctime from time.h, common functions and the usage. So here we'll just take a look at the syntax of how these functions are getting used. So printf, scanf, malloc, and free. This is how a standard usage is. So we already saw malloc and free, right? String copy, source and destinations, various mathematical operations. So I'll let you explore this on your own. These are just sample references for your uh, understanding. Coding best practices. This is crucial and extremely important because here, if you do not have your best practices in place, you could end up spending nights in the office if something goes wrong. So it's very important to understand the standard practices for writing a maintainable, readable, and efficient code. So we'll talk about efficiency in advanced C tutorial. Here are some commonly recommended coding standards and best practices for C programming. Naming conventions. So as a programmer, you really need to understand that tomorrow you are working on one file, but day after or a week later, somebody else would be working on your file in a collaboration kind of an environment or a setup for a project. So it's really important for you as a programmer to understand that it is not only you who's going to refer that file, but it is a group of people who would be referring to your file tomorrow. And it's important that you give meaningful and descriptive names either to your files or to your variables and function names, so that it is absolutely crystal clear for people who are reading your file that what exactly are you trying to achieve or what is logic written. You have to follow camel casing naming convention. Camel casing is nothing but first is a smaller case and the second is a larger case. So here, or a snake case. So avoid single letter variable names except for loop counters, which is fine. Indentation and formatting, again for readability perspective, for the third party who would be accessing or reviewing your doing your code review. So it's important to have standard indentation of four spaces or tabs. Clearly define the blocks with braces. Even for single statements, it's important. Maintain a consistent and readable code layout. Comments, it's important, like I said, make your code readable for any, even a dumb or even a monkey. So add comments explaining non-obvious sections of the code, okay, which might be challenging for another individual. Keep your comments up to date. Don't have any outdated comments, because it's possible that people constantly change the code and the logic and the comment becomes irrelevant. So it's important that you keep your comments relevant to the code which is current in your file. Excessive commenting should also be avoided, because it then becomes chaos wherein you spend too much time reading the comments rather than the comments basically need to be very precise and concise and to the point. Make sure that you have your comments in that fashion. Functions. Now it's important, apart from camel following the camel casing naming conventions, it's really important to keep your function names short and focused and uh, kind of dynamic, revealing the task that the function is going to perform. So let's say if I want to add or subtract or divide or multiply, just give the name as addition or add, uh, you know, so it becomes easier for the reader. Function prototypes, to declare functions before they define. Like I said, function definition should be very clear, concise, and precise to the compiler so as to avoid runtime errors. Return meaningful error codes to use exceptions or use exceptions where appropriate. We'll talk about exception handling later. So here it's really important for you to, if your function is not performing well, or if there is a break in your function due to some issues, put appropriate return values or return comments or print something so that you get to know where exactly your function is breaking. Memory management. Like I said, memory management is extremely crucial and important because our systems have limited memory, and as a programmer, it is your job to ensure that you manage your memory very smartly. So, free allocated memory to avoid memory leaks. Okay, avoid using global variables when not necessary, because global variables are going to get stuck in the memory unless you actually release them. Global variables, the memory will not reclaim the place for the memory will not reclaim those variables because they're global and they're crucial for the function, for various modules in your uh, larger application. So as far as possible, try avoid using global variables because that memory is lost. Be cautious with pointers and ensure proper error handling. So pointers, like I said, don't keep them dangling, as in don't keep them unreferenced inside the memory, because they consume a lot of space and they could create a lot of problems for you when at the runtime of the program. Error handling. Like I said, check the return values of the functions, put appropriate printf statements in your C programming languages so that you know where you're breaking if the program is not functioning as expected. There should be meaningful error logging and debugging. So include guards. So include guards, what do we mean by, include guards is basically to ensure that in order to avoid multiple header files, it's typically suggested that you include guards. Constants and variables. Now we spoke about constants, hashtag define const for constants, or uh, prefer constant variables. Avoid using magic numbers, use named constants instead. So it's generally recommended to avoid using magic numbers and use constant instead of global variables. So portability, like as coming from the point of indentation, formatting, function management, the most important, which also ties into portability, wherein be aware, write a portable code that can run on different platforms. Don't always be aware of the deprecated functions. Always use latest functions from the latest libraries. Write the code which is portable and can run on different platforms. It should be platform agnostic, uh, in a way where you can just port or lift and shift the code, and it should be able to run on any other platform. Testing is very crucial. You need to write the unit test cases for critical functions inside your program or inside your application. You also need to perform stress testing for boundary variables. You should consider using CUnit test variable testing framework. There are multiple testing frameworks which we'll speak of during our advanced tutorial, but research on the latest and the best testing frameworks for the language and incorporate those frameworks to test all possible critical scenarios, of course, boundary scenarios, and also to check the happy scenarios and worst case scenario. Boundary scenarios are nothing but your worst case scenarios. Version control, of course, we are expected to use the standard version control systems. The industry practice is to use Git, but you could switch to any other version control systems which your customer demands or your organization demands, such as Bitbucket, etc. And most important thing when we use the version control system is to understand the branching feature that the version control systems provide. Most of the people do not understand this and utilize the branching, which will help you, manage your uh, features better, manage your releases better, and also help you manage the bug fixes very, very efficiently. Documentation, it's really recommended, which ties into the again the portability and readability aspect of the code, wherein you need to document what your project is about. There should be a README file attached with the instructions on building and running your program, and also it's a best practices to document public interfaces and prototypes when you are writing programming code. So keep in mind these are at a very high level and fundamental ones, but there are advanced ones as well, which you will, encounter as and when you start working in the industry and move above and beyond your standard programming at your desktop. So practice. I would highly recommend. Probably you should take a screen grab of this, and if you are a very beginner or a no voice kind of a person who's just learning or at the very beginning of their career, I would really recommend for you to practice a lot. Practice the data structures, practice the syntax, practice the looping structures, specifically practice file handling and arrays, because it will give you so much of confidence on the programming language. Like I said, this is a fundamental programming language, and once you m- make your foundation with C absolutely clear, any other programming languages will be a cakewalk for you. So there are huge amounts of online references and resources. If you are a very if you are a beginner, uh, uh, there are multiple international authors and there are books that you can look at. There are online learning platforms where you could code online and test yourself online. You could also refer to the documentation here. I would recommend, as far as Indian author is concerned, I would recommend Let Us See by Yashwant Kanetkar, which has really helped me learn a lot when I was a student and learning the programming language. So take a screen grab of this as well, and do check out Let Us See by Yashwant Kanetkar. Final notes and summary is key point for the programming language. Like I said, it's a foundational language. It's very important. If you could spend a little bit of time and effort in understanding the memory management, it will really help you in the long run. Standard libraries, of course, and the coding standards that we spoke of. Uh, my encouragement to my audience or my students would be to practice regularly, explore the advanced topics. So we have not really, uh, delved into the advanced topics such as data structures, algorithms, multi-threading, uh, stack, linked list, queues, etc., which are much more advanced concepts, error handling. So I would recommend for you to first practice, understand the syntax, try practicing the semantics, understand the programming language, then slowly step towards the data structures such as stacks, queues, linked lists, multi-threading, error handling, and try to build some real-world projects. So if I could give you some references, most of the real-time trading systems that you see in the markets are built using C and C++. I would also recommend you to participate in hackathons or any other coding challenges, online coding challenges, or in person coding challenges. Join the communities and collaborate and share your work, learn more, stay curious, and finally become. Uh, I would rather recommend my audiences. My suggestion would be to become proficient in C because it's really a rewarding journey. Embrace the challenges, seek assistance, and celebrate your progress. Happy coding.